Hello, this is the generally approachable Sudoku for the 29th of March 2024. It is Me, Myself, and I by Bill Murphy. Yeah, by Bill Murphy. It is a non-consecutive Sudoku, so very interesting rules that are not actually visible on the board right now. So let's take a look at them. Normal Sudoku rules apply, so place the digits 1 to 9 in every row, every column, and every 3x3 box. Adjacent cells must not contain consecutive digits. So no two digits that are touching each other can be consecutive, meaning they cannot differ by exactly 1. So for example, something like a 4 here is invalid because the 4 and 5 are consecutive digits that are adjacent to each other. And that applies for every single digit in this grid. And so yeah, those are all the rules. With that, let us just begin solving. Right, so I mean, we should begin this like regular Sudoku, I think. You can see a sequence of digits from 1 to 8 here, and down here it's 2 to 9. And then here we have another sequence of digits that contain 9 distinct digits. So that's cool. I guess what we shall begin with is 8 in this box. Can't be in those cells, can't be in those cells because it can't be next to 9. So 8 is one of those cells. Therefore in this box, 8 must be one of those cells. Alright, I am foreseeing this to be quite a long solve because, well, I'm not entirely sure why, but it does seem to be quite a long solve. I will note that this does also seem to follow X-Wing, the X-Windmill kind of pattern, but I'm not going to use that to solve the puzzle. Could probably do the same for 2, right? Yeah, 2 in this box. Can't be here because of this 2, can't be beside the 1, so it must be one of those cells. And therefore in this box must be one of those cells. What else can we do? 4? Oh yes, 4 in this box. Can't be in those cells, can't be next to a 5 because 4 is consecutive to 5. So 4 must just be here, which places 8 down here. Therefore 6 we can do the same thing. 6 can't be next to 5, therefore 6 must be here, placing a 2 over here. Those digits therefore must be 1 and 9 to finish the column. 1 coming next to 2, so it must be a 9 here, 1 down there. To finish the box, those digits are also 1 and 9, but I don't think there's a real distinction we can make right now. Yeah. Okay. Next up. We can probably do the 3 here. Yes, 3 in this box. Come in those cells and come in next to 2 as well. So 3 in this box must be here, which means 8 goes there. Those digits are therefore 5, 9 to finish the box. And actually 9 coming next to 8, so 9 goes the other spot. Okay. We can continue by saying, I think 7 in this box cannot be next to 8. So 7 must be in this cell. 2 must therefore go here. Those digits are therefore 1 and 5. 1 coming next to 2, so this is a 5. That's a 1. Oh, okay. Nice progress. This has to be, I think, 6, 7. I don't think we can resolve that just yet. And those have to be 3 and 4, which again cannot be resolved very well. Yeah, actually they don't really see anything very... Yeah, they don't really see much, do they? The 4 is only affected by 3 and 5, and those digits will be far away. Okay. Well, let's keep going. 3? Not really. 6 is sort of similar, but again, not really. I guess. No, not entirely sure at all what to do here. 2? Yeah, I guess 2 in this box. Because of those 2 can't be in those cells. 2 cannot be next to 3, so 2 can't be in that cell, so 2 must go here. Which means in this box, yes, 2 can't be in those cells, so 2 must go here. This 7 I just saw resolve this 6-7 pair. So this 3 will resolve this 3-4 pair, as expected. That digit is therefore just a 1 to finish the column. And we have a triple here. So those digits are 3, 5, 6. 5 must be in that cell up there. So this is 3 and 6, which I don't think we can distinguish right now. This has to be 1, 4, 7. Which just so happens to be those exact digits. They also happen to be the digits that are all one more than a multiple of 3. Oh, in fact, yeah, all of these digits. Yeah, actually, this is roping, isn't it? Look at that. Roping is an effect where the same set of digits appears in each like mini column. Wrong color. Each digit appears. The same set of digits appears in quote unquote each mini column in the box, in a band of boxes. So this has to be 369 as well. And this 369 here will help us resolve that. Now, an interesting thing about non-consecutive Sudoku is that when I first saw it, right, I first looked at it and I first kind of wondered, is this non-consecutive Sudoku always going to have roping in it? And the answer is, honestly, I have no idea. A lot of the puzzles seem to have roping in it, and the reason why is because you generally want to enjoy the same set of digits close to each other. In fact, having this 1 mod 3 means that no matter how you arrange the digits in each set, there is no way you can have consecutive digits. So the only way to actually fix this will be to look at the sideways connections, but actually makes setting a lot less restrictive. And so generally a lot of non-con puzzles have this sort of roping style, and in fact roping will occur on every single row and every single column. So here you can see roping happens in the row as well, and therefore I would assume in the column, although I can't be entirely sure. So yeah, this is actually a really fun fact. It is possible to make a puzzle that is not having roping though. There are non-consecutive puzzles without roping in them, and I guess it sort of makes a bit more sense to think about it then. Like, it's way easier to form a puzzle with... It's way easier to prove that there is no roping than there is always roping, I guess is what I wanted to say. But we've sidetracked enough here. Okay, let's take a look at this set over here. This has to be 9, 8. 7 here resolves that, because that can't be an 8. Next we have... we had something here. Is it the 8s as well? 8s? Yeah, 8 in this box must be in that cell. So that forms another triple, which I think has to be 4, 7, 4, 5, 7. 5 can't be in there, so 5 has to go up here. Oh, 7 resolves this. Okay. Oh, which means that 3 here should resolve this 3, 6. Yeah, it does. Cool. And now this has to be 1, 4, 7 to finish the box. This has to be 3, 6, 9 to finish the box. So yeah, more roping. And in fact, the exact same digits that were roping on the other side as well. So that's not 3, that's not 6, that's not 9, that's not 1, that's not 4, that's not 7. It very easily causes there to be pairs along the rows, which means that each row over here just has a final pair to work with. This has to be 7, 8, that's resolvable. This has to be 1, 2. Can't resolve that yet at all actually. And those digits are therefore 4 and 5, which we can also resolve. Okay, as for this one would be 5 and 6. Now it's resolvable. This has to be 8, 9. Yep, that's resolvable. And this would have to be 2, 3. And that resolves. So this 2 resolves this 1, 2 pair, which then goes here to resolve this 1, 9 pair. Alright, and the final stage over here is probably just a final non-consecutive deduction when you spot. Like this 5 over here means that digit cannot be 6, so that must be a 3. Resolves this entire triple up here, which then moves to this side over here. Cool. And on this side, we can probably do the same thing. Yep, 5 coming next to 4, so it must be next to 7. Therefore, this would be 1, that's a 4. Therefore, that's 4, that's 1, sorry. That's 7, that's 4. There you go. Solved the puzzle in 8 minutes and 37 seconds. Can't read numbers apparently. Okay, so yeah, that was a really nice puzzle. Allowed me to kind of demonstrate the idea of roping very well. I have made a puzzle before where roping will help you solve puzzles decently well. I don't know if I want to put it in the description or not, but yeah, I have a puzzle that is sort of centered around the idea of roping, which I think is such a cool concept because it's like, it's over such a large area, you know, and like it just seems so pretty. But yeah, I hope you enjoyed this video. I'll see you guys next time. Bye bye.